Everybody in Math 2. This is probably the last video that I'm going to be sending you guys. This is the last week of instruction. We're going to be finishing up the quadratics. We did all three forms already. The last thing we're going to do here is just convert forms. We're going to change from factored form into trinomial form. So we've already done both of these forms in the last couple of weeks. Factored form was 2 weeks ago, trinomial form was last week. And all we're going to do is change, or in other words, convert from one form to the other. We're going to keep it super basic. I'm going to run through one example problem, and everything is pretty much going to be just like this. Hopefully you think this is pretty simple, pretty easy. Some of you are already asking me questions this morning, so I just want to make sure that everything's clear, because this shouldn't be too hard. As if you know what you're doing, this should be a quick, easy week. Okay. So let's go ahead and jump into this first example. We're given the function f of x equals 2 times x minus 5, x minus 1. So you might recognize this, hopefully you recognize this as being in factored form. And we're going to change the quadratic function from factored form into trinomial form. Okay, trinomial form is the one where it says ax squared plus bx plus c. So we're just going to expand it out into all the trinomials. All right, well, how do you do that? Good question. It's just a matter of distributing. We're just going to use the distributive property, simple as that. So everybody should be aware of how to FOIL, first outside, inside, last, or if you have other distribution methods, that's fine too. I'm going to go ahead and distribute the way that I showed you guys in the past, which is, let's take this value x, and let's distribute to each one of those terms. Now for the 2, just for a second, I'm going to hold off on that 2. So I'm going to ignore it for just right now. So x times x, that's x squared. And then x times negative 1 is negative 1x. And I'm just going to write negative x. Okay, good. So that's those two. Let's go ahead and switch the color up here. And now I'm going to go negative 5 times x and negative 5 times negative 1. So I'm doing the same thing that I did with the first term, but now with the second term, then negative 5. And so that's going to give me negative 5 times x, which is negative 5x. And negative 5 times negative 1 is positive 5. Plus 5. Okay, good. So we have x squared minus x minus 5x plus 5. And then let's not forget about that 2. That 2 is still in the front. I am just kind of ignoring it for right now. And don't write it like this. Make sure that that 2 is affecting everything. Just like those parentheses here, got to make sure those parentheses here. That's very important. Okay, so now we can combine our like terms. That 2 is just going to hang out in the front. Do we have any like terms here? Yes, we do. I see negative x and negative 5x. These two are like terms. What is negative x minus 5x? Well, that's an invisible 1 right there. So what is negative 1x minus 5x? That's going to be negative 6x. And then plus 5. Perfect. So all I did was combine like terms in that last step. And now we're going to continue. We're not done yet because we still have this 2 out in the front that I have to distribute in. So just to recap, I distributed these two parentheses. This 5 minus x minus 5 and the x minus 1, I distributed that out and combined like terms. Now to continue with the distribution, I'm going to distribute the 2 into everything. And so now that 2 is going to go here, and there's 3 terms now, so it's got to go to all 3 of them. All right, so let's take a look what that looks like. 2 times x squared is simply 2x squared. The next one is 2 times negative 6, which is negative 12x. And the last term there is positive 5, so it's 2 times positive 5, which is going to give us positive 10. And then there we go. There is our trinomial form, which is also called standard form. It's good to see that. So we've changed the quadratic function from factored form, this was factored form, into trinomial form. Here it is. Okay, good. That is the main meat of what we're doing. That's the majority of what I want to talk about. Now, these bottom questions, These I already talked about in previous weeks. We'll just go through a little recap right here, but I'm not going to tell you anything new right now. Other than maybe where to look. X-intercept. The easiest place to look for x-intercepts, and let me get a color here. The easiest place to look for x-intercepts is in factored form, which, by the way, I mentioned that trinomial form is sometimes also called standard form. Well, factored form is also sometimes called intercept form, because you can find the intercepts very quickly. Now, I'm not going to go through the work here. Go back 2 weeks ago where I did factored form videos so that you can see how to do factored form x-intercepts. But the two x-intercepts here are going to be 5 and 1. That's x equals 5 and x equals 1. So if I was going to write that as coordinates, that would be 5, 0, and 1, 0. 5, 0, and 1, 0. And again, if you are not sure about where I got 5, 0, and 1, 0, go back to the factored form video I did a couple weeks ago. Okay, y-intercept. The y-intercept is most easiest found in trinomial form. And it's this last value here. And I covered that last week. So that is going to be 10. And if I write it as a coordinate, it's going to be 0, 10. And if you don't remember how I did that, go back to last week's video where I talked about trinomial form as I do that. So we've got our x-intercept, easiest from factored form, and I've got my y-intercept, easiest from trinomial form. Okay, opens up or down. Now these two, let me get factored form in the chart and see this before we get that covered. These two bottom questions are going to be dependent on the a value. And recall that the a value is that number in the front. So for us it's 2. You could see it here or here. So you can see it in factored form at the front or in trinomial form in the front. It's always right there in the front. It's also called the leading coefficient. Okay, so a, our leading coefficient, also called our scale factor. It tells us if it opens up or down, and it tells us if it's wide or open. And again, I talked about these in previous weeks. It opens up if A is positive, and it opens down if A is negative. So we see 2. Is 2 positive or negative? Well, 2 is positive, so that means we know it opens up. In the cases like number 4, where the A value is negative, then we know that that opens downward. And then that's it. Okay. Now what about the wide or narrow? Here we're going to look at the absolute value of A, and then the absolute value of A just means that we're not going to consider the negative. It's the positive only. So we're going to think, is A greater than 1, absolute value of A is greater than 1, or is the absolute value of A less than 1? And let me make these ones look more like 1. Okay. If it's greater than 1, you know what, I should have switched over on this. Let me just go ahead and swap this around. This actually is 1. Okay, if the absolute value of A is less than 1, that's going to be y. And if it's greater than 1, that's going to be narrow. So now I've got this in the right order. Let me just keep it here. Wide is this one. Narrow is this one. So let's take a look at what we have. We have 2. Is 2 less than 1 or is 2 greater than 1? Well, 2 is greater than 1, so our answer is narrow. So narrow is our answer. So we know it opens up, and we know that it's narrow because A is positive and greater than 1. Okay. Well, what about this example here? I just want to take a quick look at the A value in number 2. The A value in number 2 is negative 1/4. So we know it's negative. Let me jump down on the other way here. And we know it's negative. So is that up or is that down? Well, negative tells us down. So we know that this is a down number. And it's 1/4. So the absolute value here tells us we're not going to look at the negative. We're just going to look at the actual number, which is 1/4. Is 1/4 less than 1 or is it greater than 1? Well, 1/4 is less than 1. So we know that that's in y. Opening. And there you go, just like that. The homework and the quiz for this week are very, very similar. It's all the same kind of converting the factor form into trinomial, not the other way around, just factor to trinomial, just like that. The majority of the questions in the quiz are just this here. There are a few questions, I think 3 or 4 questions that involve this bottom stuff. But for the most part, you're just going to have to distribute like I did. And they're all the same. There's just one little quick thing I want to bring up. This form here, this is still factor form, but you notice that it doesn't have 2 parentheses like before. Instead of having 2 sets of parentheses, 1, 2, it just has 1 set of parentheses with a square. So I want to make a quick point to make sure that you guys don't make a mistake that is very common. This square means, well, what does square mean? Square, when the number is square, that means it's multiplied to itself, right? So like 5 squared means 5 times itself, 5 times 5. So we're going to do that exactly the same here. If you see x plus 1 squared, that means you're going to do x plus 1 times itself. So that's exactly what I'm writing here, x plus 1 times itself. So this one will be x minus 1 times x minus 1. And then the 3 hangs out in the front, and now it looks just like this example here. Do not do, and I'm going to do this in red. Don't do this. Do not distribute the 3 inside and get 3x plus 1, or sorry, 3x plus 3 squared. This is not okay. What I did is I distributed the 3 in first. Don't do that. If you do that, you're going to be multiplying by 3 twice. You're going to get an extra factor of 3, and then your intercepts are going to be wrong, and it's going to be unfortunate. So don't do that. Make sure you distribute the parentheses first with the square, then multiply the a value. All right, cool. So that was a quick look at your homework. I gave you the answers for 1 and 2 right here. I'm only going to grade 3 through 6. And of course, the quiz and everything are due Friday at 2:30. And that will be the last of the assignments for the semester. I hope everybody did a great job, did their best. I'm going to accept all late work. So if you've got things that you want to turn in late, please get them to me by Monday. And I'm going to be updating all the grades this week. All right, that's it for me. And I will talk to you guys later.